This is day 2 of the midterm review packet, which is also the big trig final, which is the final for trig. Brought to you in part by having a calculator which cannot double as a cell phone, which cannot be shared in class. Here we go. Number 15 says solve for the following missing parts of the triangle. And it says assume that angle C is a right angle. So the first thing we want to do is not be like Tim Westwood. We want to draw a right triangle. And again, it says C is the right angle. So whatever you decide to label A and B, no big deal, as long as C is the right angle. Now they tell you to solve for all the parts of the triangle. So it looks like we're trying to find the measure of angle C. Looks like we're trying to find the measure of angle A. Whoops. And then the measure of angle, whoops, that was ridiculous. The measure of angle A, and then the measure of angle B. And then, let's see here. It looks like we're trying to find side B. Okay, so let's see what we already know here. They give us measure of angle C, that's 90, we know that. They give us A, well A equals 8, and then C equals 10. Well, from here, we can do a couple of things. Let me see here. We can do, to find the measure of side B, we can use a Pythagorean theorem. So we can say 8 squared plus B squared is equal to 100 squared. So that, I'm sorry, not 100 squared, 10 squared, which is 100. Do it again. Okay, so now we get 64 plus B squared equals 100. So then B squared equals, what's 100 minus 64? 36? So then B equals 6. Awesome. Okay, so if B equals 6, now we can find the measure of angles A and B. So what we can do is we can actually say that, let's see, if I wanted to use cosine, I would say cosine of A. Now, whenever you're given a situation, I always recommend you use cosine over sine, okay, because cosine doesn't have an ambiguous angle like sine does. So I would say use cosine of A is equal to adjacent over hypotenuse, so that's 6 over 10. So then what you do is you divide 6 by 10 in your calculator, and then you do inverse cosine of that. So A is going to equal 53.13 degrees. And then you just add that to 90, and then you subtract that from 180. So measure of angle B should be 36.87 degrees. And this is all you need for your answer. Who asked for 15? Anybody asked for 15? Nobody? Gone. All right. Okay. 44. Using the law of sines, determine the number of solutions and blah, blah, blah. Okay, so A equals 58 degrees, A equals 26, B equals 29. Okay, because we are given an angle and side, how many possible triangles are we going to have for the law of sines? 2 possible triangles, so let's draw both of them. If I call this A, B, and C, this is 58, 26, 29. Let's go ahead and draw the other one too. A, B, C. This is 58, 26, and 29. Okay, so let's do the law of sines real quick on the first triangle. If I go sine 58 over 26 is equal to sine B over 29. I'm going to multiply both sides by 29 to get sine B by itself. So I have 29 sine 58 equals sine B, so I'm going to do this in the calculator. So 29 times sine 58, make sure you're in degrees for this one, divided by 26. Now I'm going to go ahead and take inverse sine of the answer. So I get B is approximately equal to 71.07. Now, that is for the left triangle, so 71.07. Now the right triangle, I'm going to go ahead, the right-sided triangle actually. How do I find the angle of B in the right-sided triangle? How do I find that out? Chris? 180 minus the answer. 108.93. Now, Is this right-sided triangle possible? Yes, it is, because 108 plus 58 doesn't equal 180. It doesn't exceed 180, so we're actually okay on this triangle. So now we need to finish the law of sines twice for this particular problem. So b equals 108.93, and now we need to figure out what angle C is, and then side C. Yeah. 180 minus the answer. Okay, so now I'm going to figure out angle C on the left side of triangle. So that's 71.07 plus 58, and then minus 180. See, on the right side of triangle, C is going to equal 50.93. And now you just do law of sines again to find the measure of side C. So that's going to be sine of A over 26, I believe. Sorry, A should be 58. I apologize. Equals sine of 50.93 over C. And then from here you just cross multiply. So boom, boom. So you get, let's see, C equals 26 sine 50.93 divided by sine 58. I just skipped a step on that one, so hopefully you guys are able to follow it. 26 times sine of 50.93 divided by sine of 58. Okay, little c on the left triangle is equal to 23.80. So these three are your answers here. 1, 2, 3. Now we have to do it again on the right side. So 108.93 plus 58 minus 180, 13 degrees, 13.07. Oops. We got like 23 point something, right? For that triangle. 23.80. And this is 50.93. Gabby, stop. Yeah. Why? Who knows why this triangle has two possible solutions? Elliot. Because you're solving for an angle and you're using law of sines. Nope. Okay, so this angle right here is 13.07 degrees. Okay, so now let's do law of sines again. So sine of sine 58 over 26 is equal to sine 13.07 over, looks like C. So we get C equals 26 sine 13.07 over sine 58. So sine 13.07 times 26 divided by sine 58. Okay, we get 6.933. And it should make sense. The biggest angle has the biggest side. The medium angle has the medium side, and the small angle has the small side. Same thing here. Biggest angle is 70, has the biggest side. Medium angle has the medium side. Smallest angle has the smallest side. Okay, so that one should make hopefully a little bit of sense. Okay, so that was 44. 46. Law of cosines. Solve for the triangle. So, let's see. They say B equals 60 degrees, A equals 14, C equals 21. Okay, so now, if I go and draw this triangle out, sometimes I like to just draw it out because then I get to see visually what I am actually solving for. So B equals 60 degrees, A equals 14, C equals 21. So it looks like I'm trying to solve for B, angle A, and angle C. So B equals something, the measure of angle A equals something, and the measure of angle C equals something. Okay, so let's go ahead and solve for, I don't know, B first. So that means that b squared is equal to a squared plus c squared. So that's 21 squared plus 14 squared minus 2 times 21 times 14 cosine 60. So 21 squared, 441, plus 14 squared is 196, minus, 42 times 14, 588, cosine 60. And that's what b squared equals. Okay, 441 plus 196, 637, minus 588, cosine 60. What's the biggest mistake that everyone's going to make right now? They're going to subtract 588. Can't do that. You've got to do 588 times cosine 60. So 588 cosine 60. Is that really 294 right off the bat? Oh, I guess it is, yeah. Okay, and then 637 minus answer. Okay, so I got b squared equals 343. This is kind of a cool problem. I kind of like this. 18.5. Okay, so b, take the square to both sides, b is approximately equal to 18.52. Okay? So again, I'm just punching stuff into the calculator. That's all I'm doing really at this point. I'm going to erase this. I'm going to do solving for an angle this time. So if I solve for, say, angle A, then it's going to be a squared. So it'll be 14 squared equals b squared plus c squared. So it'll be 18.52 squared plus c squared, which is 21 squared, minus 2ab cosine A. So 18.52 squared is 342.99. So 342.99 plus 441 minus 18.52 times 21 times 2, 77784. Equals 196. Now, 342.99 plus 441, 783. This is 783.99. So I'm going to do 196 minus the answer. So I get negative 587.99. I'm going to divide that by 777.84, and that's going to equal cosine of A. And then I do inverse cosine of both sides. So A, holy crap, A equals, Dustin? Oh, crud. Thank you. 587.99 divided by 777. Thank you, Dustin. Which is why my answer is actually 40.8 degrees. Thank you, Dustin. That was, I was wondering, I was like, why the heck did the answer come out like that? 40.89. Cool. And then from there, you just use the 180 rule to figure out angle C. Max. No. Round it to the decimals. Okay, so now we've got 40.89 plus 18.52 minus 180. 120.59. Okay? That's how you do a law cosine problem right there. I would anticipate a couple of these on the quiz, on the midterm, which is the big trig final, which is the midterm for this quarter, but it's also the final for trig. Thank you, Chris. Trig loves you too. All right. Okay, I'm going to save 52 for later. All right, I'll save it for tomorrow because really we're not going to have enough time to do it. I'd rather focus on like an identity, like 88. Okay, everybody, it's going quiet down, please. Okay, guys, this is probably, I would say this is probably one of the more easier identities. Okay, so you might want to make sure you know how to do this. The left side is the easier one to tackle because it factors into sine squared theta minus cosine squared theta times sine squared theta plus cosine squared theta. And that all equals the right-hand side. Now, remember, this is a fourth degree polynomial, and it's being subtracted, which is basically a difference of two squares. Who knows what happens next? Again, this is one of the more basic identities. It's really, really simple. What's going to happen next? What do you think? Tony? Not that part. Julia? The plus turns into 1. So you end up with sine squared theta minus cosine squared theta equals, what do you know? It was the right-hand side all along. Okay? So again, that is one of the more basic identities. I find it to be relatively simple. That was 88. 89. Oh, another identity. Ah, okay. Ah, wow. Okay, this is my chance for redemption. Okay. I did this yesterday with period 4 and something went terribly wrong, but let me see if I can redeem myself this time. I'm going to turn this into 1 minus cotangent squared theta times 1 plus cotangent squared theta. And that's going to equal 2 cosecant squared theta minus cosecant to the 4th theta. Okay, so 1 plus cotangent squared theta is cosecant squared theta. And that's going to be times 1 minus cotangent squared theta. Okay, now I'm going to redistribute it back in. I'm going to say cosecant squared theta minus cosecant squared theta times cotangent squared theta equals right-hand side. I'm going to transform cotangent squared theta into 1 minus, oh, sorry, not 1 minus. Let's see here. Cotangent squared theta is cosecant squared minus 1. Cosecant squared theta minus 1. And that's all being multiplied by cosecant squared theta, and then don't forget a cosecant squared theta on the outside. Now I'm going to go and redistribute this section in. So negative cosecant squared times cosecant squared is negative cosecant to the 4th theta. Here I get negative times negative is positive cosecant squared theta, and don't forget I had a cosecant squared theta there all along, and that equals the right-hand side. I'm going to combine like terms. A positive cosecant squared and a positive cosecant squared becomes 2 cosecant squared thetas minus cosecant to the 4th theta, which equals the right-hand side, which was always 2, whoops, not secant, cosecant squared theta minus cosecant to the 4th theta. Redemption from yesterday. Did I lose anybody on that problem? I'm going to forego the rest of the questions, and I'm going to do a couple of logarithm problems for you. Chris! You didn't know that logarithms are going to be on the big trig final? Yes, they are. Okay, everyone, quiet down, please. Tony, thank you. Okay, this problem here. Remember, your properties of logarithms. Both logs are being added together, which means their answers are being multiplied. So if I create a single log base 4, I have 2 parentheses x squared plus 2 equals 2. Now, I am stuck because I don't have a logarithm on the other side that I can cancel it out with. So when I'm stuck, I have to change forms. Thank you, Gabby. So it turns into 4 squared equals 2 parentheses x squared plus 2. So now I have to divide both sides by 2. This is 16 divided by 2, which is 8, equals... Okay, sorry, Chris. Okay. Okay, so let me just do it in a different order then. 4 squared is 16, yeah? 4 squared. All right. Okay, so let me backtrack again. I changed forms, right? This is 4 base exponent. So this becomes 16 equals 2 parentheses x squared plus 2. And then I divide both sides by 2. Oops. Oh, hey, I didn't know you could do that. Huh, cool. Anyway, divide by 2, so you get 8 equals x squared plus 2. And then you get 6 equals x squared, and then x equals plus or minus root 6. Now, which one of these answers doesn't work? Which one of these answers doesn't work? Dustin. Why do they both work, Gabby? Because it's being squared. Gabby! Good job. Because the x is being squared. Right? All right, everybody, quiet down, please. All right, I'm going to do another one with you guys. 122. Okay. Log base 3 of 36 minus log base 3 of 15 over 8 plus log base 3 of 5 is equal to log base 3 of 4x. Now, we've got logarithms flying all over the place. What's the biggest mistake that I'm going to see people make on the midterm this Friday? Max. They're going to cancel out all the logs. Good, Max. They're going to cancel out all the logs before they combine them. So, I need to create a single logarithm. Remember, the answers here are being divided, which means that the logarithms are being subtracted, which means that the answers are being divided, which is the same thing as being multiplied by the reciprocal. This is going to tack on using multiplication, and all of that equals log base 3 of 4x. From here, I can cancel those out. That becomes a 3 on bottom. I can cancel those out. That becomes a 12 up top. 12 times 8 is 96. So log base 3 of 96 is equal to log base 3 of 4x. Now that I have a single logarithm on both sides, now, only now, can I cancel the logarithms out. I get 96 equals 4x, x equals 24. There are enough logarithms on this quiz, on this midterm, to lower your grade by 1 grade. Yeah. So if you destroy the trig and you blow up the logarithms, the best you can get is a B. Right? Okay.